Okay, so section 3.4 here is on the multiplicity of 0. Not really anything new because we're still going to use what we've learned in the last 3 sections, but this time we're going to use the factors to help us draw the graph of a polynomial function. So it says the number of times a 0 of a polynomial function occurs. That's what the multiplicity of 0 is. So, and remember, the 0 of a function is just when we find out at what value it crosses the x-axis. So that's when y is equal to 0. So it says if x minus a is a factor that is repeated n times, then x is equal to a is a 0 of multiplicity n. So just from what we learned with the 0 factor theorem, if x minus a is a factor, then that means x equals a is a 0 of multiplicity. So for example, if you had a function whose factors were x minus 1 times x minus 1 times x plus 2, then we would say, taking this x, this is the x minus a right here, so x minus 1 is equal to 0, so x is equal to 1. X plus 2 is equal to 0, so x is equal to negative 2. So that would be the value of those if we substituted in that our function would be at 0. So for this one, we have a 0 of multiplicity 2 at x is equal to 1, and a 0 of multiplicity 1 at x is equal to negative 2. So all that is saying is at x is equal to 1, it's going to cross twice, and at x is equal to negative 2, your graph is going to cross once. So it says the shape of the graph close to a 0 depends on its multiplicity. So if it's a multiplicity of 1, it's going to have a little bit of different shape than something with a multiplicity 2 and a multiplicity 3. What's going to help you in this section is if you refer to that kind of summary chart at the end of section 3.1 that gives you the different shapes of a graph if it's a degree of 3, 4, 5, and 6. And you already know degree 2 is a quadrilateral is a quadratic, so it's a parabola shape. So in these 3 examples here, if we take a look at this one, each of these 3 spots crosses the x-axis once. So this one here, when it's crossing the x-axis, it has a multiplicity of 1. That means you have 0 multiplicity 1. In this example here, it's crossing here, but at this point here, it's tangent. And if you look at the shape, if you just think of the shape from here to here, it's a parabola. So we know it's a quadratic, so that means that it would have to be an x squared to get that shape. So this one, wherever it is tangent, means that there is a multiplicity of 2. So this graph here would have a 0 of multiplicity 2 and a 0 of multiplicity 1. So altogether then, this would be a degree of 3. Each one of these is a degree of 3. In the last example here, it is crossing at this point, and it's also tangent at this point. So if it to be crossing and tangent, means that it has a multiplicity of 3. And if you look at your graphs and, on that, I think it's on the 5th page of 3.1. When we have a degree of 3, then we have those 3 points. There has to be 3 crossings on the graph. So this one right here at this point here would be where it is crossing, and then the tangents are just going to occur right beside that. So it says the multiplicity of a zero or root can also be referred to as the order or the zero of the root. So we've talked about roots to a solution, zeros of a solution, the solution to a quadratic. All of those mean the same thing, that you're finding out what does the x equal when y is equal to 0. Okay, so knowing that the number of times it crosses or is tangent on a graph will give us the degree. If we know that, then we can find out what the possible degree of a function is, and then we can also figure out the leading coefficient, x-intercepts, and describe the end behavior for the graph. So if we call these A, B, C, and D, the 4 things we're going to do here. So the least possible degree. The least possible degree means we have to take a look at the zeros of the function and see, are we crossing, are we tangent, or are we doing both crossing and tangent? So if I take a look at this point here, it's crossing at this point, and it's tangent at this point. So that means that this would be a multiplicity of 1, this first one. The second cross here is a multiplicity of 1. The third cross over at this 4, 0 is a multiplicity of 2. So this one crosses the x-axis at 2 points. And then it touches, or is tangent, same thing, at 1 point. So that means we have a multiplicity of, where it crosses is 1, where it crossed again is 1, and where it touched or was tangent was 2. So if we add those all up, it'd be a degree of 4. Okay, B part asks you to find the sign of a leading coefficient. So if you take a look at those graphs, in order for your graph to have a leading coefficient, and I'm trying to find the correct one here, it should be, this graph is going down in quadrant 3 and going down in quadrant 4. So the leading coefficient is going to be negative, because it should be going, if it was a positive, it would go like this. It would be a right side W, right side up kind of looking W. This is an upside down W, so that means this has a negative leading coefficient. So it's going down in quadrant 3. And because we know it's a degree of 4, so it has our highest power is going to be x to the power of 4. So the graph of x to the power of 4 should be an upright W. Because this is a down or upside down W, we know that the leading coefficient is going to be negative. Okay. Next step says the x-intercepts, and we want to find the x-intercepts and the factors of the function with the least possible degree. So if we take a look here, we have x is equal to -5, then we have x is equal to -1, and we have x is equal to 4. So those are all the x-intercepts. If we substitute this back into the x minus a form, this would be, because this is x equals a is the way they have it written there. If we change it back to x minus a, this would be x plus 5, x plus 1, and x minus 4. So all I've done is taken my number and put it on the other side of the equal sign. So in this case, I've added 5, I've added 1, and I've subtracted 4. So those would be your 3 factors of the function, and they are in our least possible degree. Because and what that's saying here is there might be some that have a higher multiplicity in 1, which mean they would have a higher degree than 1, but all we do is we just write that. X minus 4 had a multiplicity of 4. So instead of writing it as x minus 4 times x minus 4, we just put multiplicity of 2. Okay, and then D part asks you, at what points is the function positive and where is it negative? So my positive intervals. Positive interval just means where is it above the x-axis? Negative interval just means where is it below the x-axis. So between here and here, it's positive. And if I look at every other part on this graph, everything else is below. So I've only got one interval where my graph is positive. So that's in between -5 and -1. Negative interval then is where is this graph in the negative part of that y-axis. So everything to the left of -5 is negative. Everything to between -1 and 4 is negative. And then again, it's negative after -1. So my negative intervals occurred at 3 locations when x was less than or not equal to, because at -5 it was 0. So when it's less than -5, when it was between -1 and 4, and then again it was negative after 4. Okay, so when it's asking you to describe the graph, that's all where the positive and negative intervals are, that's all you're doing, is you're looking to see when is it positive and when is it negative. Okay. All right. Same thing for this graph then. We're going to look for where is it tangent and where isn't it tangent. And then we're going to look for the spots on the graph where it's crossing and what would the multiplicity be at where it crosses. And then do the positive negative intervals and list the factors. So on this one, I take a look here. At this point here, it is touching it or tangent, and at this point here, it is crossing it. So it's tangent once and crosses once. So tangent once means multiplicity of 2. And crosses once means multiplicity of 1. So that means that my degree is going to be 3. B part says to describe or to find the leading coefficient. So if I take a look at this one, it is going up in quadrant 2 and it's going down in quadrant 4. And if it's doing that, and we know that it is a degree of 3, then this must be a negative graph, because if we look at degree of 3, our graph should be going like this. And I had mentioned you could use the last chart on page 3 on your notes in 3.1, but also the second page has this on it as well. Page 2 of your notes in 3.1. So it should be going this direction if it was positive. So because it's the flip of that, then we know it is going to be the negative, because this one is going up in quadrant 2 and down in quadrant 4. That means we have a negative leading coefficient. So C part says, now tell me the factors for this. Well, at x is equal to 2, negative 2, sorry, that's a multiplicity of 2. And then at x is equal to 3, it's a multiplicity of 1. So if we write this as a factor, this is going to be x plus 2 times x plus 2 times x minus 3. So again, all I have done is taken my a value and moved it to the other side of that equal sign. So I just do the opposite operation. Okay, D part says, where are we positive and where are we negative? So positive is anything above that x-axis. So after this point, it's positive. In between here and here, oops, it's positive. It's positive, it touches 0 there, and then it's positive again here, and then after, at this point on, it's negative. So my positive interval occurs at x is less than negative 2, and then it was positive right, and I broke it up into 2, but we could actually go right through there. So between negative 2 and 3, and then it was negative after 3, so everything greater than 3. Okay, so now we're going to do the reverse. We're going to take a look at the actual polynomial function, and then say what the degree is, say what we think the leading coefficient is. Based on the degree, we'll be able, and the leading coefficient, we'll be able to describe the end behavior. We can take a look at the factors that are there and find the zeros. We can solve for the y-intercept, and then we can say where it's going to be positive and negative. So the degree of this one, if I take a look, I've got a cube and then basically a power of 1, so I know my degree is 4. Leading coefficient. So I don't have any negative that is being multiplied at the beginning of this. I've got a positive in front and a positive in front. So that means it's going to have a positive leading coefficient. And if I look at my factors, it's just an x and an x. So it's just going to be a 1x, in this case, to the power of 4. So my leading coefficient is a positive 1. So if I take a look either on page 109 in the textbook or on the second page of the notes, a degree of 4 with a positive leading coefficient makes that W shape. So it's going to be going up in quadrant 2, and then it's going to be going up in quadrant 4. So it could look something like this, where this is my axis going through here. So I'm going up in quadrant 2, and then it'll do its little bumps and squiggles and still go up. Sorry, that should be quadrant 1. So it's up in quadrant 2, up in quadrant 1. The zeros or the x-intercepts. So if I take a look at how my factors were x minus 2 cubed and x plus 1. So that means this is x is equal to 2 and x is equal to negative 1. So my zeros are going to be x equals 2 with a multiplicity of 3, and x is equal to negative 1. And you could write multiplicity of 1, but you don't need to. Okay, my y-intercepts. Well, y-intercept is just that x equals 0 and solve. So I have 0 minus 2 all cubed times 0 plus 1. So negative 2 cubed is negative 8 times 1 is just negative 8. So that means my y-intercept would be at 0 and negative 8. Intervals where the function is positive or negative. This is easier to do once you have graphed this. So to graph this, what I do is I take a look at the function that I have. So I have x minus 2 cubed. So I know at x is equal to 2 is where it's going to either touch or cross or do both, depending on the multiplicity. And at x is equal to negative 1, it's going to touch or cross or do both, depending on the multiplicity. So at x is equal to 2, and I'm just going to tick these off at every second one. So this is x is equal to 2. X is equal to negative 1 will be here. And then my y-intercept is important because that's going to tell me where this graph is going to cross that y-axis. So I'm going to go down just by ones. 1, 2, 3, 4, 5, 6, 7, 8. So this is negative 8 there. Label my axis because it isn't on here. So at x is equal to negative 1, it's a multiplicity of 1. So that means at this point here, my graph is going to cross. So I'm going to start here, or wherever, doesn't matter, and it's going to go down to that negative 8, and that's where it's going to cross. At x is equal to 2, it has a multiplicity of 3. So multiplicity of 3 means the same as degree of 3. And a polynomial function with a degree of 3, if you look on your chart, means that it has to do this. So at one point it's going to cross and be tangent. So that means here at 2 it's going to go like this, and then it's going to go down like this, and I have to go back and cross through that 8. So that's what this graph would look like. Okay, if you wanted to see just a little, it would kind of be going like this. So then my, right here would be my x-axis. There would be my y. So then now I can say where is this interval, where are the positive intervals and where are the negative intervals. So any place where it's above the x-axis is where it's positive. So from here on it's positive, and from here on it's positive. My negative occurs in between these points. So positive intervals are at x is less than negative 1 and at x is greater than 2. Negative interval occurred in between there. between -1 and 2. So that's it. It's done. Okay, next example. I have negative x cubed plus 13x plus 12. Well, I know it's a degree 3, so I can write that in here because that is my highest power. My leading coefficient, I have a negative in front of here, so I know my leading coefficient is a -1. Degree 3 and a negative coefficient means that for a degree 3, it should have been doing this if it was positive, but because it's a negative, it's going to go like that. So my end behavior then is that it's going to be going up in quadrant 2 and down in quadrant 4. Okay, my zeros are my x-intercepts. I need factors. So that means that I have to actually factor this function before I can do anything with finding the x's or the zeros. So this is where our zero integral theorem and our factor theorem and then synthetic division come in from last section. So the first thing I need to do is I have to factor out that negative. So I'm going to have negative x cubed plus 13, oh, not plus, it'll be a minus 13x minus 12. Okay, so now I use my zero integral theorem and my factor theorem. So I list all of my factors of -12. So plus or minus 1, plus or minus 2, so this is for 12, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So those give me my whole list of factors. So now I can do my zero factor theorem, or my factor theorem, not your zero factor theorem, and see what the right factors will be. So I'm going to start with, I'm going to substitute in, oops, +1. So I have -1 cubed minus 13 times 1 minus 12. So I have -1 minus 13 minus 12. So 1 minus 13 is -12. -12 minus 12 is going to be -24, so I know that's not going to work. So I'm going to try -1. And you don't really even need to worry about your negative sign in front of here when you're doing this, because even if you substitute it in, if it equals 0, then it doesn't matter if there's a negative in front of it or not. So I have -1 cubed minus 13 times -1. Whoops, I don't need a bracket there, I just need a minus 12. So I have -1 plus 13 minus 12. So -1 plus 13 is plus 12. 12 minus 12 is 0. So this means that a is equal to -1. So if I substitute into x minus a, my factor is going to be x minus -a, so x plus 1. So x plus 1 is a factor. So now I use my synthetic division. So I have 1, do my T-chart looking thing. I have a 1 cubed, a -13, and a -12. So I automatically bring down my 1. So for this one, when I go across, I'm going to multiply by 1. When I go down, I subtract. So 1 times 1 is just 1. I subtract negative 13. Oh, I made a mistake. I need my 0 in there, right? Because remember, when you're substituting these in, you have to have a placeholder for each one. So this one should have had a 0x squared. So I go across, I have 1 times 1 is 1, 0 take away 1, negative 1. I go across, multiply, negative 1 times 1 is negative 1. I go down and subtract, negative 13 minus negative 1 is a negative 12. Go across, negative 12 times 1 is negative 12. Negative 12 minus negative 12 is 0. So that means then, these are my coefficients, and if I started on x cubed, then this is for the x squared, the x, and the coefficient. So I have x squared minus x minus 12 is what I'm left with. This can factor, product and sum. Why did I put negative 3? It should be a negative 1. Negative 3 is, or 3 is a factor. So this works out to be negative 4 and 3. So my factors are x minus 4, x minus 3. So if I put it all together, for my function, I had that negative 1, or just the negative, whatever you want to do, that I factored out. My factors were x minus 4, x plus 3, and then the one I found using the zero integral theorem and the factor theorem was x plus 1. So that means each one of these has a multiplicity of 1, so they're each going to cross the graph at those points. So my zeros are going to occur at x is equal to 4, x is equal to 3, negative 3, x is equal to negative 1. So again, all I've done is just moved my number to the other side of the equation. So my zeros or my x-intercepts are at x is equal to negative 3, negative 1, and 4. My y-intercept, I can find that right now. If I substitute a 0 in there, I have negative 0 minus 4 times 0 plus 3 times 0 plus 1. So that's going to be negative 4 plus, or negative 4 times 3 is negative 12 times 1 is negative 12. And then I multiply by my negative in front, so this was negative 12, so it's at positive 12. So my y-intercept occurred at 0 and 12. So I have those points. Once I have all of my intercepts, I can plot them and then draw my graph. So again, across the x-axis, every second line is going to be a line, and then going on the y, I'm just going to use every one. So 1, 2, 3. So there's 12 right there. So at negative 3, I had a cross. At negative 1, it crossed, and then at 4, it crossed. So knowing my graph from my leading coefficient and degree is supposed to go like this, that means that it's going to do this. And remember, I have to cross up here at the 12. So it's going to start here, go down, cross, go back up to the 12, and then come back down and cross again. It's a bad shape, but you can see the idea of it. So integrals where it's positive, or intervals where it's positive and negative. So it's positive between, or right after this, and it's positive in between here. It was negative between here and then negative after there. So it's positive at x is less than negative 3, and then again when it's in between negative 1 and 4. My negative integral, and I don't know why I'm having trouble, interval is in between negative 3 and negative 1, and then again after 4. And then it's done. So your assignment is on page 147 in the textbook, and you can do questions 1 to 5 will give you a good idea of how to do this. 1 to 8 is just going to give you a little bit more practice on it.